First, a reminder of equivalence that you'll see in two other parts of the syllabus. This video is going to be about trig. Now, equivalence is not the same as an equation. In partial fractions, you may see something like this, where what we're saying is there's some combination of a and b that are going to make the right-hand side equal to the left-hand side for every value of x. And so you have two methods if you realize it's an equivalence, not an equation. An equation would be solved to find a value of x or two values of x. This is saying for all values of x it's the same. Now, the first technique you're allowed to do is you're simply allowed to put values in. Now, in partial fractions you put clever values in, x equals 2, and then I like to say what I'm doing, x equals 2, so the left hand side is now 5 and the right hand side is b times 2 minus 1, which is 1, so b is 5. Then we would put in x equals 1 and find a. Nice. So that is the first thing you're allowed to put, because it's true for all x values, you can put in an individual x value. The other thing you will see is something like factorizing cubics. And so you're asked to factorize this cubic, and you're told that one of the roots is a convenient low integer, because this is the only way we can do it. So we guess x equals 1, and we work out what this is, and we're looking for it to equal 0. When you put x equals 2 in here, this adds up to 0, so we know that x minus 2 is a root. Now, I'm not saying this is an equation here, and so I prefer not to use this symbol. The IB will tend to use it, but I prefer to use the correct symbol. So what I'm saying is, for all values of x, this is true. They're just equivalent expressions. I couldn't find x by solving this equation because it's true always. And so I've got method 1. I could put x values in, but that looks hard here. And the other method is called comparing coefficients. So if I compare the coefficient of x cubed, well, I've got 1 on the left-hand side. I must have 1. So x times this, well, that has to be 1. Similarly, I'll jump to the other end and say I must have minus 12 there. So there must be a 6 there, because minus 2 times 6 is the only way I could get a constant out of this. And now I can find this value here. And then let's look at the 16x. I didn't do that one because it's negative. I want to get a 16x out of this. How do I get an x out of this? Well, I could have x times 6, so that's 6x. But I've also got minus 2 times whatever that is. And I'd probably show a bit of working here. I would write it down. Compare coefficients of, in this case, let's go for x. So I've got 16 is equal to 6 minus 2a, and I can find a. Turns out to be negative 5. And then I would attempt to factorize this quadratic, which it doesn't have to, but it normally will, and I'll end up with 3 factors. This one does. So that's equivalence. Okay, let's go back and have a look at this topic in trig form. You can see the same question written in two very different ways in trig. It may say something like, write this in that form. It's actually technically not on the syllabus, but very much the sort of thing you should be able to do. As soon as you write it like this, it is on the syllabus. So 3 cos plus 4 sine is equal to this. But the crucial thing here is it says this is true for all x. So this is not a trig equation. This is a trig identity. This, by the way, is the symbol for all that is not on the syllabus. So as soon as you realize it's an identity, not an equation, you should write it that way. And simply putting this symbol in should trigger in your mind saying, oh, I know what to do now. I can either put in a specific x value, or I can compare coefficients. Now, before you do that, you should be looking at this equation saying, can I use the formula book here? And you sure can. There is compound angles, so let's just do that. And now we do have a lovely compare coefficients question. How many cos x's do I have on this side? 3. How many cos x's do I have on this side? R times cos alpha. Same for sine. So I would tell the examiner what I'm doing, and I would write it like this. Here is my question. I'm going to compare coefficients. I'd write the words on my exam script and say, let's have a look at cos x, it's this, and let's have a look at sin x, it's that. And so now I have, I'm in the topic of difficult simultaneous equations, and this is an important little trick for top students. When you have simultaneous equations that have no pluses or minuses in, consider simply dividing them. So I did a bottom one divided by top one. I hope you can see why I did that. But this often happens when you have equations set up like this. Look at the way these r's are just going to cancel. Lovely. And now you see why. That is just tan alpha. So I find alpha. Alpha is equal to inverse tan of 4/3. And here is an absolutely gorgeous trick for finding r. Simultaneous equations, I'm going to square them and add them. It seems utterly insane. So I've squared and added them. Obviously I get 25 there. What do I get here? Oh look, cos squared plus sin squared is 1. Factorise the r squared. This whole thing is simply r squared. And so r is 5. Absolutely lovely.